The first new exoplanet captured by James Webb, here's what it means. The James Webb Space Telescope has made history once again. For the first time since its deployment, this groundbreaking instrument has captured a direct image of an exoplanet, marking a significant milestone in our ongoing search for worlds beyond our own solar system. The newly discovered planet, JWST, is nestled in what scientists call our galactic backyard, just around 100 light-years from Earth. Although it might sound distant, this is relatively close on a cosmic scale, making this discovery all the more significant. Since coming online in 2022, the James Webb Space Telescope, often referred to as JWST, has revolutionized our ability to explore the universe. Unlike any telescope before it, Webb can peer deep into space with unprecedented sensitivity. But until now, it has primarily been used to study known exoplanets in more detail, analyzing the composition of their atmospheres and assessing their physical characteristics. The discovery of JWST marks a turning point. This is the first time Webb has successfully identified a previously unknown exoplanet, showcasing not only its analytical power but also its potential as a discovery engine. This particular breakthrough was achieved using an instrument on board Webb called the MIRI, or mid-infrared instrument. Attached to it is a special feature known as a coronagraph, which is designed to block out the overwhelming brightness of a star, much like an artificial solar eclipse. This allows the telescope's infrared sensors to detect much fainter objects, like distant planets, that would otherwise be lost in the glare. It is a technological feat that enables astronomers to see what was once invisible. The target of this successful imaging session was the star JWST, first identified by the Hubble Space Telescope back in 1999. At just 6.4 million years old, JWST is a baby compared to our Sun, which is approximately 4.5 billion years old. The young star is still surrounded by a dense disk of gas and dust, believed to be the birthplace of planets. From Earth's perspective, this disk is oriented face-on, giving astronomers an unobstructed view of its complex ring structure. Within these massive rings, more than 100 times the distance from Earth to the Sun, lies a bright anomaly located in the second ring. This unusual light source piqued the interest of astronomers. After ruling out alternative explanations, such as a distant galaxy or a stray object at the edge of our solar system, they confirmed that the light was coming from a newly discovered planet. This world, named JWST, is relatively small and cold, with a mass estimated to be similar to that of Saturn. Remarkably, it is at least 10 times lighter than any other exoplanet that has ever been directly imaged, making this a rare find in planetary science. To put this into context, most of the nearly 6,000 exoplanets identified so far were found using a different method, by detecting the slight dimming of a star's light when a planet passes in front of it. These are known as transit detections. Capturing direct images, especially of small and faint planets like JWST, is far more challenging due to the overwhelming brightness of the stars they orbit. But the Webb telescope has now proven that it is up to the task. According to Anne-Marie Lagrange, lead author of the study and astronomer at the Paris Observatory, Webb has already been observing many planets that have never before been directly imaged. This discovery showcases not only Webb's imaging capability but also its potential to vastly increase the number of exoplanets discovered through direct observation. Lagrange notes that Webb has improved the ability to directly detect planets by a factor of 10, a game-changing leap for the field. Why does this matter? Because the holy grail of exoplanet research is to find smaller, rocky worlds like Earth or Mars, planets that may harbor the right conditions for life. To reach that goal, scientists first need to study a wide variety of planetary systems, understanding how they form and evolve. Only then can we determine whether our solar system is a unique cradle of life or just one of many. The discovery of JWST is a step in that direction. It helps scientists test theories about how planetary systems develop, especially around young stars like JWST. The more we know about gas giants like JWST, the better we can predict where smaller, potentially habitable planets might form. Lagrange emphasizes that the eventual goal is to find Earth-like planets. But that journey requires us to understand planets of all types and sizes. Looking ahead, the capabilities of Webb are expected to expand even further. Astronomers anticipate that the telescope will soon be able to identify planets even smaller than TWA-7b. But to directly image planets as small and temperate as Earth will demand even greater observational power. That is where future observatories like the extremely large telescope, set to begin operations in Chile in 2028, come into play. Instruments like these will be crucial in capturing the first direct images of Earth-like worlds, opening new chapters in the search for extraterrestrial life. The discovery of TWA-7b is more than a technical triumph. It is a powerful reminder that we are living in a golden age of discovery. With tools like the James Webb Space Telescope, we are no longer merely speculating about distant worlds, we are seeing them with our own eyes. And in doing so, we are inching ever closer to answering some of humanity's oldest and most profound questions. Are we alone in the universe? Or is there life waiting to be discovered in the faint light of another world? NASA just found mysterious Martian minerals inside a Troublemaker rock. Mars is a world full of secrets, and some of them lie just beneath the surface. On June 3, NASA's Perseverance rover took one more step in uncovering those secrets. It drilled into a Martian rock, blew away the debris, and began a close examination of what lies inside. The rock, nicknamed Kenmore by the mission team, became the 30th target of Perseverance's abrasion campaign, a process that begins with carving out a 5 cm wide patch on the rock's surface. But this wasn't an easy task. According to Ken Farley, deputy project scientist at Caltech, Kenmore was a weird, uncooperative rock. It appeared ideal at first glance, stable, promising for both abrasion and potentially even sampling. But as the process began, vibrations and flaking occurred, making it difficult to get a clean abrasion. Still, the team pushed just deep enough beneath the surface to carry out the scientific analysis they needed. Why go through all this trouble? Because the surface of Mars is dusty and weathered. To really understand the composition and geological story of a Martian rock, Perseverance must grind away that outer layer. Doing so reveals a fresh, flat surface that its instruments can analyze directly. The process begins with a purpose-built abrading bit that grinds into the rock. Then comes the cleanup. Instead of a traditional wire brush, Perseverance uses an advanced tool called the Gaseous Dust Removal Tool, or GDRT for short. This system fires a concentrated puff of nitrogen gas, 83 kilopascals in pressure, or 12 pounds per square inch, to blow away the debris from the abrasion. 5 puffs per sample, 1 to vent the tanks, 4 to clear the dust. So far, the rover has used this cleaning method 169 times since landing in Jezero crater over 4 years ago. Roughly 800 puffs remain. There's a reason NASA chose nitrogen puffs over brushes. Brushes could carry Earth contaminants, but the gas jet method is clean, ideal for preserving the integrity of Martian samples. Once the surface is clean, the rover gets to work. A close-up imaging tool named Watson, mounted on the robotic arm, moves in to capture high-resolution images. Then from its elevated position on the rover's mast, the SuperCam instrument begins its scan. Using a powerful laser, SuperCam fires thousands of pulses into the freshly exposed rock surface. Each laser strike vaporizes a minuscule portion of the rock, and a spectrometer captures the composition of the resulting vapor. SuperCam also uses additional spectrometers to analyze light, both visible and infrared, bouncing off the abraded material. In the case of Kenmore, this revealed something remarkable: clay minerals embedded in the rock, a strong sign of past water activity. According to Kathy Quanton-Nataf, a SuperCam scientist from the University of Lyon, the clay minerals contained hydroxide molecules bound to iron and magnesium. These are typical features of ancient Martian clays, offering clues to a wetter, possibly habitable Mars. SuperCam's findings were only the beginning. 2 more instruments, Sherlock and PXL, followed up with their own in situ analysis. Sherlock used Raman and fluorescence spectrometry, while PXL conducted X-ray-based lithochemistry. Both confirmed the presence of clay, but also identified additional minerals. One of them, feldspar, is commonly found on the Moon and is known for its high reflectivity. Even more intriguingly, PXL detected manganese hydroxide, a material never before observed by the rover during its mission. This discovery opens new doors to understanding Martian geochemistry. Now that Kenmore's analysis is complete, Perseverance is already moving on to its next exploration target, continuing its journey along the rim of Jezero crater. Each new rock, whether cooperative or stubborn, brings a chance to gather more data for future missions. As Farley explained, not all Martian rocks are equal. Understanding their differences is essential. The more we learn now, the less future missions will have to guess. Knowing a rock structure could one day help determine whether it's safe to drive over, suitable for building habitats, or even usable for extracting elements like hydrogen and oxygen for fuel. But it's not just about science, Perseverance is also setting new engineering records. On June 19, during Sol 1540 of its mission, the rover broke its own record for the longest autonomous drive. It traveled 411 meters, over 4.5 football fields. That's 64 meters farther than its previous record, set in April 2023. The rover's AutoNav system allows it to plot and navigate its own path, cutting down on the time scientists spend manually planning each move. According to rover driver Camden Miller, Perseverance could have gone even farther, but they stopped exactly where the science team had planned. That pinpoint accuracy is no accident, it's the result of daily learning, calibration, and refinement. Each sol on Mars is a lesson. Every meter driven and every rock examined adds to humanity's growing understanding of the red planet. From Kenmore's stubborn resistance to the subtle clues of ancient water hidden in clay, Perseverance continues to show us that Mars is far from a dead world. It is a planet with a deep and dynamic history, one that we are only just beginning to uncover. And with every new discovery, we get closer to answering the age-old question, was Mars ever home to life?